Hello, and welcome to the first episode of Orlando's Musical Experiments. With this series, I hope to try and play around with some unusual instruments one may find in toy stores or thrift shops, and see if one can make music with it. So first up, we have a First Act Discovery keyboard. It's a kid's toy made in 2011, and I got it from Jade, so thank you. Hopefully, I won't completely destroy it. What really makes this interesting are what look to be ports, or rather where ports should be on the back of the keyboard. I'll show those in a minute. So let's turn this on and check it out. This is supposed to be a piano sound. This is an organ sound. Let's check polyphony. Whoops, wrong order. Hold the top key down first. Okay, so it's only a 4 polyphony keyboard. Okay, so we need a headphone jack. I know where we can get one. It's from... No, not James Franco, but from Jameco. If you want to try what's going to be attempted, here's the part number to type in. It's 208-1334. However, since it was already on clearance from the time of this recording, the manufacturer number is 354-3PY. So while we're here, let's take a look at any specifications. It's a 3.5mm mono jack, so no stereo, but that's okay. No actual, specifications, I see. Oh well, this is an experiment anyway, so let's get started. The audio jacks have just come in, and here's what they look like. They are tiny, and if you notice, there are pins sticking out. Keep those in mind. You'll see why these were selected later. Since this is going to require a bit more knowledge and skill than I possess, I'm going to need help. So I asked my dad, DesertSandman, to help me out with this project. Sandman, say hello.
Hello. First thing we need to do is take the batteries out and a place to put the screws. It's a good idea to use a screwdriver that's magnetized because some of these screws are getting stuck. Anyway, I always wondered why they design stuff where plastics clip together at one end and they use only one screw to hold everything down. I don't think it would have been a bad idea to do that for this guy.
Well, this keyboard is already 99.9% plastic.
That screw won't come out. I need a stronger magnet.
We can always magnetize the screwdriver by running a magnet over it.
Well, if you have a rare earth magnet, take and tack it onto the screwdriver, and it will increase the magnetic flux on it.
How about attaching this to the screwdriver? Nope, I think they are stuck to the plastic.
Oh well, we'll just pick up what we can, and if they fall out, they fall out. We still have 4 screws that are in there.
You might have to push them out from underneath.
Any fallout?
Nope, nothing.
Time to disconnect the battery and the keyboard. Now this can go away. Here's where the jack is going to go. You can see it's in line with the plastic piece you can knock out at the back of the keyboard. We got a few more screws here. Once I get this out, I'll put the jack in here and see how well it lines up with the back of the keyboard. I can see there are a lot of parts and jumpers that are missing. This board is partially assembled. Well, look at that.
Wow.
It was designed to fit there.
Like a glove.
This board was designed for that plug. It looks like it was designed for some components to go right in here. What kind of components, I don't know yet. Jumpers, resistors, capacitors, I don't know. This outside one here goes around and attaches to here, whereas this one goes to here. This is your ground, which goes to here. I'm wondering if this keyboard would work if we were to take and tap one of these leads to ground. So normally how this would work is the sound going to the speaker goes to the jack, and the connection to the jack is connected to the speaker. So without a jack, sound would go to the speaker. When you plug in a jack, it breaks the connection to the speaker, and now the sound goes to the jack. But on this board, the trace connects the 2 connections together. I'm going to need a voltmeter to confirm this. Looking at the silkscreen trace, there are additional components for connecting the jack. Some of these are missing, so it's hard to tell if there are supposed to be jumpers or resistors here. But it looks like capacitors go here. This 104 would be its value, and that value would be 0.1 microfarad. Now how that relates to the backside, I don't know. I'll set the voltmeter for continuity to check the copper traces on the board. Since there is no continuity between these 2 traces, they are isolated from each other. But some of these traces are going to here and here. The center trace is ground. Looking at the top of the board, you can see the power plug and underneath the trace goes all the way back to the center trace. This is ground. This is positive. At this point, I'm trying to figure out how the engineers who originally built this circuit to work with this jack. This is a big thinking process, so don't get discouraged. This does take some time. Plus, you don't want to rush and end up bricking the thing, or making it a paperweight. Without any specs on this chip, this really is just guesswork. However, I do know that I won't be able to do it the way I originally planned. Tapping into one of the speakers will require quite a number of modifications to the copper traces. I'm wondering if this really is designed to where plugging something into here doesn't turn the speakers off. It just gives you an audio out. So how can we test this? I'm going to need a few more things to probe the board at this point to see if we get sound. I am also going to need some wire for jumpers and some capacitors. After studying this board, I've concluded there is a separate connection on the chip for this, and this makes sense. If you want the output going to the speakers, you're going to need some power to drive the speakers. But if you want the output to record or listen through headphones, you don't need power for that. So this is going to be a bit more complicated than originally thought.
Okay, so let's get a few more things. Be back after a fade out. We're back, and we brought a speaker for testing the sound output, some resistors, jumper wires, probes for continuity testing, and some capacitors.
Let's go ahead and partially reassemble the keyboard and test my theory. Oops. I forgot to turn this off the last time I used it.
Are the batteries dead?
I think it's okay. It still has a sting to it. Oh, by the way, before testing a 9-volt battery with your tongue, make sure it's not leaking acid.
Good safety tip.
Okay, where were we? I need to find a way to hook up ground. Looks like this resistor goes to ground.
Oh good. We're grounded.
We're going to need a capacitor. I'm going to use it as a probe. So let's see where I can probe on the top side of the board so I don't have to turn it over. Alright, it appears to be working.
Is the cable in the way?
Yeah.
Oh, wow.
I think I got this figured out. Boy, that's a pretty good output.
Yeah, you're going to have to put a resistor on that, otherwise the audio is going to clip. The sound is also coming out of the internal speakers.
Okay, so shall we get all the parts and put this together?
Yeah. Do you want to use the sponge?
No. You never want to use a wet sponge on a hot soldering iron. It will damage the tip. When you constantly put a hot soldering iron on a wet sponge, you can crack the tip because of the drastic temperature change. Always use the cleaning pad because it will clean the tip without changing the temperature. So I'm going to desolder these two joints. These two and those. Uh-oh, I damaged the foil. I'm going to need something to steady the circuit board.
Like my Mr. Seven Hands?
Yeah, I need it so the board isn't jumping around so much when I'm soldering.
You got it.
Let's give this another shot. There we go. That's better. This is a 0.1 microfarad capacitor. That number there helps you determine the capacitance. This number is in picofarad. This number is a 1, 0, and 4 zeros that follow it. So to go from pico to micro, you move the decimal point 6 places to the left. So the decimal point will be in front of the 1, making this a 0.1 microfarad. That is how you read the numbers. Actually, that number is the same one that's on the board where I'm going to put them in. That's what I'm guessing is what's supposed to go there. I'm guessing there's some capacitors that go here to ground, but I'm not sure because there's no values there. However, now that I'm looking at it, there's probably a 1 microfarad capacitor that would go in there, but that's just an afterthought. These two capacitors and these two resistors are what we are adding. As well as the jack. Now, how to hold that in place? I got it. This will work. Crossed over. This tip is almost too big. Oh crap!
What?
The foil just came up. The solder just crossed over again. I'm being as delicate as I can, but for some reason the solder isn't cooperating. Well, I don't think it's going to hurt anything. but I need to fix the foil. I'll do that by adding some solder around the joint. I'm just cleaning the circuit board there. Looks like there might be some solder splattered on it. I just want to make sure there's no shorting. There doesn't appear to be any. There does appear to have enough foil to do this. But the solder doesn't seem to want to flow. I'm going to need more resin. Now that everything looks okay, let's check for continuity. Look, as I'm shaking this, the foil came loose. I'm going to run some more solder over this. This is turning into a mess.
This was kind of cheaply made, so I'm not surprised.
So now that we have continuity, the next step is to partially assemble the keyboard and test it with something that we can plug into it. I also need something to knock out the plug. That snapped right out.
Oh, wow.
That board was designed for this plug. The board is a little off from the mounting holes, but it's not a big deal. I was thinking about the capacitors there because when you plug something into this, it's going to pick up electromagnetic stuff that could feed back into it. The capacitor would filter that out.
Did you bring any?
No, I didn't.
Well, let's just go ahead and try it first to see if it works.
Oh, look. This thing was so quickly made they didn't even bother to cut off the excess wires. Okay, we need something to plug into the back here.
A speaker. It won't go in.
Where's my other plug? I wonder if I damaged this thing putting it in. That fits nice and easy.
Uh-oh.
Oh my.
Yeah, that is a tight fit.
Doesn't want to go in all the way.
There we go. Brute force.
I wondered if some excess solder got down in there.
It doesn't look like all the buttons are working.
Yeah.
Uh-oh. The piano's not working now.
I can't seem to go back. I think I broke something. Wonder if something came loose. I wonder if this isn't seated all the way. This ribbon is what connects to the other board. Actually, this wire over there doesn't feel right.
Yeah, it looks like it's disconnected.
El crapo and a half. Let's see where it's broken. Yeah, it broke off. This thing just wasn't designed to be taken apart, modified, and put back together again.
Can it be soldered back into place?
I'll have to do something like that.
Or can we make a new lead and solder that back onto the board?
The wire actually broke off.
It broke off?
Okay, let's map this out. From the bottom, this is soldered. 1, 2, 3, 4. You can see it's connected here.
But not on the top side, since we already know how flimsy the foil on the board is.
Yeah, this is going to be a bit of a challenge. The more I flip the board, the more risk of wires breaking on the ribbon cable. I've got to come up with a way of fixing this without breaking it some more. I may have to take out both boards so I can flip both of them over. The wires that are here are not solid. They're stranded. That means that they are smaller wires that are twisted together. The first one is completely broken. The next one is only being held by one strand.
Is that why 2 of the buttons weren't working?
Well, maybe.
Well, I'm wondering if it would be better if you unsoldered the whole thing and find a better way of attaching it to the board.
If I do, I could end up damaging the board. I don't want to do any more soldering than I have to. You know, what I would like to do is use some hot glue to hold things down. That way, when I bend this over, I'm not causing any more stress on the solder joints. That should keep the rest of the wires from breaking off. If I unsolder this, I could mess up the foil, then I'm really in trouble. I just want to stick with the one that's broken. I want to stabilize the rest of them, so the only thing I can think of is to hot glue them down. So from what I could see, you only need one wire. That will still make the connection. Well, it's better than it was before. I think I'm going to remove the second board. That way I can flip this over as one piece. I can also get to the bottom of the first board easier.
As the Mythbusters would say, if it's worth doing, it's worth overdoing.
So it looks like 6, and the one on the end are disconnected. The first one doesn't connect to anything, so it doesn't matter. The problem now is I put a glob of hot glue on it. Man, this is turning out to be a mess.
This has definitely turned into more of a project than anticipated.
Since number 6 is right on the edge of the hot glue, I think I can pry that away. Yep, it broke. It does go somewhere. Well, at least we know which ones are broke.
Well, let's go ahead and put this away. That way we can come back to it fresh. So stay tuned, everyone. Same tech time, same tech channel.